Assalamu alaikum. This is our next class on electric field, and we are doing June 14, 41-5. So please open the question in your own past paper books. An isolated solid metal sphere of radius r is given a positive charge. The distance from the center of the sphere is x. The electric potential at the surface of the sphere is V naught. The term isolated is commonly used, and this is the style of the examiner. The electric potential at the surface of the sphere is V naught. So this is a memory sketch. The general shape is the memory coming from the memory of the question. So you have to draw a straight line first. It's a case of, if I recall this sketch, let me recall this sketch. This sketch is like this one. This is the shape. And whenever you want to draw such this potential sketch, one line comes like this, and then it goes down. This is the radius. This is 0. This is V. This is the general shape. Remember this shape whenever you are talking about potential in a sphere. Whenever you're talking about potential in a sphere, so you first have to draw a straight line till the radius. So I'm starting from the potential. Look, I have drawn this line straight. After that, the line has to go down. It's a shape. Shape already I've drawn here. And then on the double radius, it will be half. When the radius get double, it will be a point here. And 0.25, when you take it here, when radius doubles, the potential gets half. When radius doubles, potential gets half. When radius 4 times, potential is 1/4. So I have marked the points. You should solve the question. This is the year number. solve the question in your own sheet, graph sheet. You have to copy this. Complete this part. This is June 14, 41.5, and I have drawn the graph showing the working. And now let's move to part number B. The electric field strength at the surface of the sphere is E naught, full E naught, 1 E naught. On the axis, sketch a graph to show the variation with distance. Electric field strength. This is again a memory sketch. Remember, until the charge is moving inside the sphere, electric field strength will remain zero until the charge is inside the sphere. But when it touches the, look at the screen, when it touches the radius, it goes up, suddenly increases, and then it begins to decrease. I'm drawing a general shape for memory. You can find both of the sketches in your notes. This is the standard sketch. Now, this is the sketch which I have to draw, and it will be till radius, it will be zero. Electric field strength is zero. Look, it's zero till here. From there, it goes straight up till the 1E. Then you have to draw a curve. Now, when the distance double, electric field strength will become 1/4. Now, why it becomes 1/4? When we were drawing potential, it was half. Now, remember the formula. V is equal to KQ upon R. Look at the formula. And here, look at the formula. E is equal to KQ upon R square. That is why when the radius double, electric field strength is not half, it is 1/4. So this is the shape. So copy the shape on your books, ideally on your books. June 14, paper is 41, and it's question number 8. State what is meant by quantization of charge. Oh, how we got this here. This is coming from AS. This is coming from AS, and we should do that question because it will recall the AS version of electric field, but it is quantization of charge, but we can do the first part. We can do. Let's try this. Let's see if people remember it. What is meant by quantization of charge? Anyone can recall what was the statement quantization of charge? No one responded. Quantization of charge was a concept in our AS. discrete amount of elementary charge. That's fine. The actual concept was there, charge on any substance. This is AS memory. Charge on any substance is always an integral multiple always an integral multiple of the elementary charge of an electron. Copy this definition for a memory callback. A student carries out an experiment to determine the elementary charge. A charged oil droplet is positioned between two horizontal metal plates as shown. Read the remaining data. If you see the notes, you will find this topic, charge particles stationary between the plates. This is the droplet. This is the weight. This is the upward force. .680 volt, 7 millimeter is the separation. And what is the charge? We need to find the value of the charge. He is giving us the weight. So let's keep it as weight. Q is equal to WD upon V. Weight of the droplet is 4.8. This is my W. And what is D? D is 7 millimeter. So now you have to copy this. You have to copy this and you have to find an answer for this working. I got one answer, 4.9 into 10 is to power minus 19. I got one answer. Now, the student repeats the experiment and determine the following values of the charge on oil droplet. We know that the charge of an electron is in our memory, in our constant figure, 1.6 into 10 is to power minus 9. This is our memory. So he wants to recalculate this value. When he says 3.3 times 10 power 19, it's double of 1.6. It means it contains 2 electrons. When he says 4.9, it contains 3 electrons charge. When he says 9.7, it contains 6 electrons. And when he says 3.4, so how we find the average? Look at this method. Total charge upon total number of electrons. So add all the charges. I'm adding the charges as all the charges have a common power, 10 power minus 19. So I'm going to take it common. So add up all the electrons and let me know, copy this calculation and let me know the answer. Copy this and I'm just coming, complete this working and let me know the answer. November 14, 41.5. Define electric potential at a point. Can anyone narrate, recall the definition of electric potential at a point? Famous definition. Is the work done per unit charge. It is a work done per unit charge. Right. So this is the definition. An isolated solid metal sphere is positively charged. The variation of the potential V with distance x from the center of the sphere is shown. An isolated solid metal sphere is positively charged. Thus, variation of the potential V distance x from the center of the sphere is shown. The graph is plotted. Use figure 5.1 to suggest why the radius of the sphere cannot be greater than 1. Because after that, you can tell examiner because it is the same shape which we were doing in the previous question. If I recall again, when you draw a potential curve for a sphere, it first go straight line like this, and then it comes down like this. This is the general shape of a graph, which is for potential, and this position is always the radius. This is a general shape of a potential graph. Now, you can tell examiner that why it cannot be less than 1 by showing the starting position of the graph. Let me mark here. And if you have the book with you, you should also mark, look, this position. One. So this is how this graph is working. So it cannot be greater than 1 because after the position 1, after x is equal to 1, the graph is bending downward. After x is equal to 1, v is decreasing. That the charge on the sphere behave as if it were a point charge. Now look at this part, that how we can say that the charge is behaving like a point charge from the graph, because it's following the curve equation. So you have to justify the examiner that how it is possible. It's a point charge. So for we write the formula, the Coulomb's law derivative V is equal to KQ upon X. So Vx is equal to KQ. Now definitely Q and K are constant. Now if the above sketch, now if this sketch is following this formula, the relation Vx is constant, then it is correct. Now take any two values, like for example, I mark here and I take this value. It is 1 and 1 and 180. I have taken this value. You can take at least 2 to 3 values to confirm examiner about that. I have taken these values. So if I try them, Vx. So if I try 180 into 1 is equal to 180. I have taken these two values. Now you can take any other two values which you can use to check. So suppose that I take 4 position and I take this. I have a 4. So can you tell me what would be this position after 40? Can anyone read for me this question mark position? This is the middle, so it will be 60. 44, huh? I think the same. 44, but it is coming in between 44. 20, 20 in 5 boxes. I think it's 46 because it's in between 44. It is in between 44 and 46. It's looking to be 46. No, the one line is 46, 44, the next will be 48. So we can take 44, 46, whatever it comes. So we can take 46, 45. Only a good observation is needed, that is it in the middle or slightly lower side. If I take 45, so I try here the second point, which is 45 into 4. 180 coming again. Now try one more point. Let's try 8. Now how much this would be? Slightly above 20. 22. How much is 22 into 8? 176. Then it's still close. Assuming that the charge on the sphere does behave as a point charge, use data from the figure to determine the charge on the sphere. So we need to find the charge on the sphere. So you have to put the formula, data from the figure. So find the values. You can get any set of values, Vx, any constant value. We are getting majority Vx 180. So if I take 180 as my reference value, the value of K is 9 into 10 is to power 9. I can find the value of Q. Solve it to find Q. Right. So we are done with this question, and we stop here, and we will continue this inshallah in our next class. Allah Hafiz.